It is time that we swap this hard-coded value for a user-provided input. To do that, we have to read from the standard input. Luckily for us, Rust provides us with a nice set of primitives that will help us to achieve that. Similar to many other languages, Rust comes with a standard library. It is a collection of useful abstractions such as hash maps, vectors, a bunch of data structures, and importantly, I/O primitives, which is what we need right now. So the standard library is an external crate, which, as you remember, is just how we call packages in the Rust world. And this crate is available to all Rust projects by default. In other words, we can just start using it. So let's go and look at the standard library documentation and see if we'll find something that will be useful for us. You can find the documentation on doc.rustlang.org/std. And here it starts with a short description of what the standard library is. But if we scroll down, we see that it also contains a list of all the modules in the standard library. If we go there, we can see that there is a bunch of stuff here. But what we actually care about right now is I/O. Here we can see that there is an I/O module. We can follow that. And now again, it starts with a short description of what the I/O module gives us. And it pretty much gives us core I/O functionality, which is great. It comes with a lot of functionality, but the thing that we care about right now is standard input. And we can find standard input right here. So this is the section on standard input and standard output. We have already used standard output through the println macro, so we know how to do that. And we can see that the I/O module gives us a read line functionality. So we can read a line from the standard input like this. So let's actually see how we would add this to our code. First, we have to bring the I/O module to our scope. To do that, we go to the top of the file, and with the use keyword, we can specify a module from a crate that we want to use. So in this case, we want to use the standard library crate, and we want the I/O module. So by specifying it like this, now we have pulled the I/O module to the scope of this file, and we can use the functionality that it provides. Now let's see how we would actually read from the standard input. As we saw in the example, we just call IO std in, and then there is a read line function on that. So we see that the read line function accepts a string as a parameter. We can actually go to its definition and see better. So it accepts a string as a parameter, which is mutable. So pretty much we have to allocate a new string and then pass it to the function, and it will fill it with the user's input. So let's see how we would actually allocate a new string. So we need a new variable. As we know, we use the let keyword. We know that this string will be modified because it will be empty, and then the function will fill it, so it needs to be mutable. And we will just name it input. So the way that we create an empty string is by actually calling the new method on a string. So string here is a struct. We haven't discussed struct yet, but we will discuss them in more detail in the next section. But for now, it's suffice to say that this function call will create a new string. Then we can just pass this string to the function here, and hopefully it will just read into the string. So if we go to the console and we try to run the code, we get an error. So it is expecting an ampersand mute string, but it actually found just a string. So what is this ampersand mute string? At least we can just try to copy that and paste it here and see if that will fix our problem. So we put ampersand mute for the string. If we go back here and we try to run it again, yeah, we see that it runs now. It's actually waiting for user's input. but that is a very weird syntax. So in the next video, and we'll actually discuss what this ampersand means and why we have to explicitly specify when we're passing mutable variables to functions.